Okay, so let's take a look at our last conic section, which is hyperbolas. Okay, if you're looking in your book, it's section 9.4. If you're using the packet, which is where the homework is, it's section 6.4. All right, so when we defined an ellipse, okay, that was a collection of points in the plane, such that the sum of the distances between a point on the ellipse and each focus always comes out constant. Okay, so you added two distances up, and they always came out the same. Well, here you're going to subtract two distances, and they always come out the same. And it's the same distances you found for an ellipse. Okay, so it's a collection of points, such that if you measure the distance from any point on the hyperbola to the first focus, measure the distance from that same point to the second focus, and subtract those two distances, you'll always get the same thing. So a lot of the words we define for a hyperbola, they're going to be similar to what we had for an ellipse. Okay. An ellipse had foci, so does a hyperbola. Okay. An ellipse had vertices, so does the hyperbola. They both also have a center. Okay. An ellipse had a major and a minor axis. A hyperbola will not. We're going to rename them. It's the same concept, but they decide to give it a different name. Okay, so next what I'm going to do is put up a picture that kind of illustrates this definition in a more visual way. Okay, so there's a hyperbola. Okay, a hyperbola is sketched in two parts. Okay? Each of these parts, we're going to learn in a few minutes, is called a branch. And C and B are the foci. Right, so if you measure the distance from a point E will always be on the hyperbola, to the focus at C, and point E to the focus that's at B. I'm going to show you what the distances come out to, and when you subtract them, it's always going to come out to 5.66. Okay, no matter where you move that point. You can also go to the other branch. Okay, and all three of these things, they're all interactive calculations. So if this number was changing when you subtracted, it would be updating, just like the other two are. But when you subtract those two numbers, it always comes out the same. Okay, and the reason we're doing absolute value is because we want it positive. Okay, so take the absolute value of it. Okay, so any question on that? So it's very similar to an ellipse, except you're looking at a difference instead of a sum. All right, so we've got our foci. Okay, notice in a hyperbola, the foci are the part where the branch would wrap around it. Okay, so that's how you can think of your foci. Whatever conic section you have, the foci are always wrapped around it. So if you had an ellipse, and those were your foci, those could be your vertices. The ellipse is going to wrap around the two foci. In a hyperbola, the branch would wrap around the foci. All right, so if you draw a line that goes right through the foci, that's called the transverse axis. What was that called for an ellipse? If you draw a line right through the foci, through the vertices as well. It wasn't called the transverse axis. What was it?
Major axis.
That was the major axis. Okay, it's the same idea. But it's math, and people like to come up with new names for things, so that's what they did. They call it the transverse axis. Okay, this idea is the same as an ellipse. If you draw in a segment connecting the two foci, and you find the midpoint, that would be the center. Okay, so if you put in a segment between C and B, found the midpoint, that would give you the center. Okay, we also have another axis in a hyperbola. And this axis is if you draw a line through the center and make it perpendicular to the transverse axis. What was this called for an ellipse? If you draw a line through the center perpendicular to the major axis. That was the minor axis. Well, that's the name we use when we have an ellipse. When you have a hyperbola, they call it the conjugate axis. So a line through the center, perpendicular to the transverse axis, it's the conjugate axis. And the two parts of the hyperbola that we draw, the curved parts, those are called the branches. Okay, it's the only conic section that you sketch, and you have to pick up your pencil to do it. It's not connected. And if you look at the point where the transverse axis and the hyperbola intersect each other, those are the vertices. All right. So the picture I had on the other page, there's your branches. There's your transverse axis. There's your vertices. And your two foci would be somewhere in here. Now, if you compare that to an ellipse, notice what happens here. The vertices are on the inside of the foci. You see that? That's not how it was with an ellipse. Here's an ellipse. This was V1. That was V2. And then the foci were inside the ellipse. F1, F2. Okay, so notice they kind of switch places. In an ellipse, the foci are on the inside, the vertices are on the outside. It's just the opposite for a hyperbola. Okay, but I think a simple way to keep that straight is remember your conic section wraps around the foci, whether it's wrapping around them as an ellipse or wrapping around them as a branch of the hyperbola. Okay, anyone have any questions on kind of the basics of a hyperbola? Any of the definitions I put up or how they compare to an ellipse? Some things are similar, some things are a little different. Okay. All right, so we're going to start out with the equation of a hyperbola just like we always do, where the center is at the origin. Okay. The formula I'm about to put up, probably not the most useful because it doesn't take into account shifting. Okay, but we'll start with this and then we'll advance to that. Okay, so the center is at the origin. A and C in a hyperbola have exactly the same role that they did in an ellipse. A is the distance from the center to the vertex. C is the distance from the center to the foci. B is a little different. Okay. B for an ellipse was the distance to the minor axis. Well, we don't have a minor axis anymore, so it doesn't make sense to define B that way. So this is the case where you're going C units to the right and to the left of the origin, and A units to the right and to the left of the origin to get your foci and your vertices respectively. So everything is going to line up horizontal. Right, so I'm going to look at that equation. And it should look very similar to something we've already done. What does this equation look almost the same as? What other conic section? Yeah, James?
Ellipse.
Yeah, it's almost like an ellipse. There's only one thing that's different. What's the one thing? Anybody see the one thing that's different? Yeah? Right. Now we have a minus instead of a plus. And just changing that one thing turns an ellipse into a hyperbola. Okay, Okay, so that's what's different in this box. Anybody notice anything different about the relationship between A, B, and C? Yeah?
Addition instead of subtraction.
Right. Yesterday it was c squared equals a squared minus b squared. Now it's c squared equals a squared plus b squared. Okay, it's a lot of little changes, but ones that if you forget about them, you mess it up. Okay, there's also one extra thing we have to find in a hyperbola that we didn't have to find in an ellipse, and that's asymptotes. Okay, these two branches, when you draw them, they're basically bounded in by two diagonal lines, two asymptotes. And the asymptotes are at y equals plus or minus b over ax. So your asymptotes always go right through the center. Well, in this case, my center is the origin. That's why there's no y-intercept on this. It's going to go right through the origin. When we shift it, it doesn't go through the origin anymore. We'll have to adjust this. Okay, and I think that's the easiest way to graph a parabola. Okay, the book had another suggestion, but I don't think that that's helpful. Easiest way to graph a hyperbola is draw your asymptotes, and that'll tell you where to put your branches. Okay, and I'll show you one. Okay, A and C are exactly the same thing they were yesterday. So if you have that for an ellipse, it's not changing. The only thing I had to do is make sure I put absolute values around the A, because it is possible we get a negative today. But if you take the absolute value of A, that's the distance from the center to the vertex. C is the distance from the center to the foci. Okay, so just remember those two things. Same as an ellipse. Okay, any questions before we look at some examples? Yes?
Wait, so B isn't a thing anymore?
Yeah, B doesn't, at least for a hyperbola, I don't really know visually what B would represent. Maybe we could draw it and try to look at it and figure out what B is. The only thing we use B for is the slope. It's the numerator in the slope of the asymptote. But visually, yeah, we won't use B when we're sketching. All right, so basically the rest of the class we'll just try some examples and see what we do. Okay, I'll do a couple graphs just to make sure we can do that too. All right, so it says find the equation of the hyperbola. Giving us focus, vertex, and the center. Anytime that they give you those three things, what two letters can you always find right away? Yeah?
A and C.
You can always find A and C. A and C are just distances between the center and the vertex, and the center and the foci. Okay, let's start with A. Distance between the center and the vertex. Okay. Brianna, what's the distance between the point 0, 0 and the point that's 2 units to the left of it? It's just 2. Okay. So all the distances here are going to be very easy to find because they're all going to be up, down, left, or right. Not going to have any distances on a diagonal. So it's just 2 units. Okay, B, we're going to hold off on for a second, and then we'll find C. Darren, what's the distance between center and the focus? 3. Now we can find C. Whoops. So now we'll find B. Okay, so B, we're going to use the formula that's similar to what we had yesterday, but we got to be careful. It's A squared plus B squared equals C squared. Okay, remember yesterday it had a minus. Okay, so just make sure we do the plus today. Okay, fill in what we've got. A squared is 4. B squared we don't know. C squared is 9. All Right, so b squared is 5, or b is the square root of 5. Okay, any questions on how we got a, b, or c? All right, so let's write our equation. So we get two fractions. Okay, always equal to 1. And what symbol should I put between them? Plus or minus for a hyperbola? Jill?
Minus.
Yep. Anytime you get a hyperbola, you're going to put the minus between them. All right, now how do we figure out where a, b, x, and y go? Well, it's different than an ellipse. A isn't always the bigger number anymore. It doesn't have to be. Okay. It's even easier where you put a and b. Always put a squared first. Always put b squared second. That never changes for any problem we do today. A squared is always your first denominator. B squared is always your second. What will change is what you put in the numerators. Okay. Which one is x squared and which one is y squared is going to control if the transverse axis is vertical or horizontal. Okay. How about Alex? If I graph the point 3, 0 and negative 2, 0, would they line up horizontally or vertically?
Vertically? No, horizontally.
Yeah, horizontally. Okay, this one is right 3. The vertex is left 2, okay, from the origin. Okay, so they would line up horizontally. If you want your transverse axis to be horizontal, put that letter first. Okay, so in this case, x comes first. Okay, whichever letter comes first, whichever letter is the positive, that makes the transverse axis go in that direction. X-axis, horizontal. Okay, and then y squared comes next. Okay, so whichever letter comes first, that's the direction of your transverse axis. It has nothing to do with which number is bigger anymore. That was for an ellipse. Okay, so there's your equation. Any question on the equation? Okay, last thing I need, if I'm going to graph it, is I need my asymptotes. Okay, what was the slope of the asymptotes? Was it b over a or a over b? Yeah, b over a. Once we do the other one, I'm going to try to give you a hint at how to remember that. We'll see if it helps. So my slope is positive or negative b over a. Now if you take the square root of 5, it comes out to about 2.2. All right, so my rise is 2.2, my run is 2. Okay, let's graph those lines. So up 2.2 over 2. Up 2.2 over 2. And then also do the negative. Okay. Down 2.2, right 2. Down 2.2, right 2. Those asymptotes give me a place to put my two branches. Okay. The branches have the transverse axis going through them horizontally. Okay, so you're going to put your branches in the left and the right part. Kind of like this. Okay, remember, as that line keeps going out, it should look like it's getting closer and closer, the best you can, to the asymptote. And that's it. Any questions on that? So somebody earlier had asked, does B have anything to do with the hyperbola visually? Well, let's see what these x-intercepts are. Okay, so if you let y equals 0 in that fraction, you'd have x squared over 4. This whole part would just disappear. equals 1. And you multiply each side by 4, you get x squared equals 4, and you get x equals 2. So I didn't sketch it perfect. The intercept should actually be at 2 and negative 2. So my graph's a little bit off, but that's okay. But I was trying to see if it had something to do with the square root of 5, and it doesn't. So visually, I'm not sure what B would be. Any questions on the sketch, though? Okay, so that's a hyperbola. Okay, this one we don't have to sketch. Giving you the equation, I just want to find out 5 things about it. Okay, so you got to give me your vertices, center, foci, which way the transverse axis goes, and the asymptotes. Okay, Cody, which one is A here? Or it's not given to you directly. You got to take a square root, but what is A?
4.
A is 4. It's always the square root of the first term. Okay, Casey, what's B?
2.
Yep, square root of the second term. Okay, C, we need to calculate. It's going to be C squared equals 16 plus 4. So it's the square root of 20. It's A squared plus B squared. Take the square root. Or you can write it as 2 square roots of 5. Okay, my center. Cole, where's my center for this one?
0, 0.
Yeah, until we start seeing plus or minus with the x and the y, you don't have to worry about shifting it. So the center is 0, 0. Okay, Andy, which way does my transverse axis go?
Horizontal.
Yep, horizontal. The x is the first one you see. It's positive. Okay, that's the key. Whichever one is positive, that's the transverse axis direction. Okay, that's important because now this tells me everything is going to be left and right of the center. Okay, Augustine, what letter is going to help me to find my vertices?
C.
B?
Wait, C.
Nope, C is going to be the foci.
Oh, yeah. A.
A. Okay, so we're going to go 4 units left and right of the center. All right, so Kobe, what would be 4 units left of the center?
0.
Yep. And how about 4 units to the right?
4, 0.
4, 0. I guess for that one, you could have just written plus or minus 4, comma 0. It's fine. Okay, foci. We're going to use C for that. We're going to go 2 root 5 units to the left. And to the right. Okay, last thing we have to find, this is the part that's new for hyperbola, is our asymptotes. Okay, Colby, what's the slope of my asymptotes? Is it A over B or B over A?
B over A.
For this one, it's B over A. So 2 over 4, which would reduce to what?
1/2.
Yep, 1/2 x. And there's your asymptotes. Okay. Any question on that? All right, pretty much every hyperbola problem is like that. That's how you do them all. Okay, here's another one to discuss. This one has one extra step you have to do first before you can discuss it. Kelsey, what's wrong with this that we can't discuss it exactly the way it is?
It's not in the right form.
Yeah, how would you get it in the right form?
Divide by 9 and 4.
Divide, what'd you say?
Or you'd have to divide.
Yeah, we're going to divide everything by the same number. We we do have to divide. What number do you want to see on the right-hand side?
Oh, 1,
1. So that tells us we have to divide everything by
36.
36. Right, so we're going to get x squared over 9 goes into itself once, 9 goes into 36 4 times. 4 goes into itself once. 4 times 9 gives me 36. Now it's equal to 1. Okay, now we can do just what we did on the last problem. All right, so in this case, A is 2, B is 3, and C is going to be the square root of 13. C squared equals 4 plus 9. 4 plus 9 is 13. Take the square root. Okay, center. Well, if you just see an x and a y in the numerator, you haven't shifted it. Center's at the origin. Okay, first term is positive, and it's x. So transverse axis is horizontal. This tells me vertices and foci are going to line up horizontally, left and right of the center. Okay, Brianna, could you tell me what my vertices would be?
Plus or minus 2.
Yep, perfect. So left 2 and right 2 of the center. And Darren, how about my foci?
Plus or minus square root of 13.
Yep, plus or minus square root of 13, comma, 0. Okay, and lastly, my asymptotes. Okay. James, what would my asymptotes be?
Y equals B over A.
So in this case, what would we have?
3 over 2.
Good, 3 over 2. Anything else I need to put with that?
X.
Yep, x, just to make it the equation of a line. X. And that's it. Those are the 5 things you need to write down. Okay, any questions on that? If you do notice a mistake or you're not sure, something seems really weird, let me know, because I might be thinking ellipse in my head and I might have added instead of subtracted or something weird. Okay, our next equation. This is going to be the case where the center is still at the origin, but now your foci and vertices are above and below. Okay, everything's lining up vertical. Okay. Foci are C units above and below the origin, vertice A units above and below the origin. Your transverse axis will be vertical. Okay, only thing that's different about this equation, it's still equal to 1. Still a squared is your first denominator, b squared is your second. But the x squared and the y squared switch places. Now the y comes first and it's positive. That makes the transverse axis vertical. Okay, relationship between a, b, and c, still the same. A squared plus b squared equals c squared. Okay, the slope on your asymptotes is going to change though. Okay, when you have the transverse axis vertical, the slope is a over b. Okay, and the best thing I could come up with to remember that, it's pretty sad, but all I could come up with is when your transverse axis is vertical, your slope is a over b. VAB. That's all I got. VAB. When your transverse axis is horizontal, you get horizontal is b over a, you get haba. That doesn't work as well. But VAB kind of works. All right, so if you remember VAB, vertical is a over b. Or just write it down on your reference sheet. Okay, so a lot of little things here. Thank you. Okay. So slope changes. You like that? I thought that was good. Made people laugh a little bit. All right, so we got that. Keep everything else the same. Okay, c squared equals a squared plus b squared. Don't change that. Let's try this one. Okay, kind of like the last one, we want to discuss it, but it's not quite in the right form. Okay, James, what do I have to do to get that so it's in the correct form? Yep. We divide everything by 4. So y squared over 4. Remember, your 4's are going to cancel here. So you get x squared over 1 equals 1. Okay, Joe, what's A?
2.
Good, A is 2. Okay, B, Alex?
Sorry, 1.
Yep. B is 1. C squared equals A squared plus B squared. A squared is 4, B squared is 1, 4 plus 1 is 5. Add them up, take the square root. C is the square root of 5. Okay, now we need to find all 5. Center? Cody, have I shifted that at all?
No.
No, until we see pluses and minuses in the numerator, haven't shifted it. Okay, transverse axis. Casey, which way is the transverse axis going to go here? Vertical. Okay, y is the positive, comes first. Whichever one is positive, that's the direction of the transverse axis, vertical. So now this tells us the vertices and the foci are above and below the center. Okay, Cole, what would be 2 units above the center?
0 plus or minus 2.
Yep, above and below, plus or minus 2. So there's your vertices. Okay, Andy, what about my foci?
0 plus or minus 1.
Okay, which letter do you use for foci?
Oh, C.
C.
So
Yep.
plus or minus square root of 5.
Yep, so you had the right idea. The 0 was good, plus or minus was good. It's just we had the wrong letter. Okay, and now our asymptotes. We just got to get our slope right. So what's my slope going to be here? Yep, 2 over 1. Did you think VAB in your head?
Yeah.
You did? All right. 2 over 1, or just 2x. Vertical, A over B. Okay, let me try to sketch that one. So we at least do one sketch that's in each direction for the transverse axis. Okay, so to sketch it, all I really need is those asymptotes. These are going to be really easy to sketch. Okay, y equals 2x. Rise is 2, run is 1. Okay, connect those. Okay, about like that. Okay, I'll make it dotted so we remember that that's an asymptote. And then y equals negative 2 over x. Okay, so it's a little bit off. All right, so down 2, right 1. Down 2, right 1. Okay, and sketch that asymptote. Okay, so draw in your second asymptote. Let's see. A little bit off. Okay, and basically that gives us a place to put our branches. Okay, so your branches here are going to be vertical in the top part and bottom part. If you want to figure out exactly, where it crosses the axis, you could do that. Okay, you could just plug in 0 for x in this case, and that would tell us exactly where it's going to cross. All right, let's do that. See if we can get exactly where it crosses. So if you fill in 0 for x, you're going to get y squared over 4 equals 1. Okay, y squared equals 4. Y equals plus or minus 2. So that's a coordinate on my graph. 0, 2, 0, negative 2. Now just make your branch right there. Okay. So there's one. And second one. Any question on the sketch? All right, this one we don't have to sketch. Let's see if we can come up with the equation. Okay, about Augustine, what's the first thing I should do to come up with the equation?
Figure out if it's vertical or horizontal, which is obviously vertical.
Okay, so we could write that down. So if it's vertical, what does that tell me?
It's going to open up and down. Well, I mean,
The branches, yeah.
and it's going to be y minus x, y squared over whatever, minus x squared over whatever.
Yeah. So we know that's at least going to be the format because your foci are above and below the origin. Vertex is above, everything lines up vertical, so you want to start like that. Next you need A and B. Well, we can't get B right away, but we can get A and C, and then we can work with that. All right, so Emily, what's A? Yep, distance from the center to the vertex is 2. Okay, B, we don't know, but we're going to need it. C, we can figure out distance from the center to the focus. That's 3. All right, so B is going to be square root of 5. Okay, so in my head I just did C squared equals A squared plus B squared. Bring the 4 over. I take the square root of it. You get B equals 5. Okay, so now when you set it up, first denominator is always A squared. Second denominator, B squared. There's your equation. Okay, any question on how we got the equation? All right. Did anybody feel like we need to go over another discuss one? Okay. There really wouldn't be anything new here. It's already set up in the format you need. It's equal to 1. So you just find A and B right away. And then you can get C. And describe all those things. All right. So the last couple we'll look at is when we shift the center. Okay. This chart is it's in your packet. Okay, and it's on page 407. All right, so notice the difference in the equation. Now x, a little bigger. Okay, x and y both have a minus with them. Okay, that minus means we're going to shift it. We're going to shift it to a new center point, and the center point is going to be hk, just like it was with an ellipse. A squared always comes first. B squared always comes second. It's always equal to 1. And if you want your transverse axis to be parallel or horizontal to the x-axis, you got to make the x come first to make it positive. If you want your transverse axis to be vertical, okay, parallel to the y-axis, it's going to be shifted, but it'll be parallel to the y-axis. You're going to make y come first. Okay, A and C still have the same relationship they always have. Okay. To find your new foci, if your transverse axis is horizontal, you're going to shift left and right C units from the center. Okay. If your transverse axis was vertical, you would shift C units up and down from the center. Okay, and A is also the amount you're going to shift from the center to get your vertices. Either shift horizontally from the center or vertically. Depends on which case you have. Okay, and then there's some pictures of the two hyperbolas. Okay, any questions on that? Okay, so again, that's all on page 407. Honestly, I don't even think of these formulas. I just try to use kind of common sense and I reason it through. Am I shifting left and right? Oh, well, if I'm shifting left and right, I'm going to add something to x. Am I shifting up and down? Well, then I'll add to y. Okay, what do I add? Well, we already know that. If you're dealing with foci, you're using C. If you're dealing with vertices, you're going to use A. Okay, the way they've written this equation right here, this I don't particularly like. okay? They've rearranged the letters a little bit, so now I think it's even more confusing. Because yesterday, we already had a minus with an ellipse, but we had the letters in a different order. We had c squared by itself. Well, they decided to get b squared by itself. And when you do that, now you have a minus again, okay? Just think of it as c squared equals a squared plus b squared. Okay, I wouldn't think of it this way. Just move those a squareds to the other side. That's not wrong, but think of it that way. Okay, so now we're going to find all 5 letters. Okay, HK and then ABC. Okay, Colby, is there any letters I can find here without really doing any calculations at all? They're just given to me? Yeah, what's H?
1.
Yep. H is 1. How about K? -2. Okay. Now we can also find A and C. We might have to do a little arithmetic in our head, but still it's not that bad. Kelsey, what's the distance between the center and the vertex?
2.
Yeah, they're 2 units apart. Then the distance between the center and the focus?
3.
Yep, they're 3 units apart. Okay, now we're going to find B, which is going to be square root 5. 9 equals 4. So it's c squared equals a squared plus b squared. I feel like we've been getting 5 or square root of 5 for a lot of these. Just a coincidence. Okay, so b is the square root of 5. Okay, and they want the equation. Well, first of all, we're going to set up the 2 fractions. Even for an ellipse, you can start that way. Now we got to decide, okay, hyperbola, do we put a plus or a minus between the fractions? Jill? Yep, we put in the minus. Okay, a squared is always your first denominator. B squared is always your second. Next, we have to decide whether we put the x squared first or the y squared first. Alex, if I graph the focus and the vertex, how will these points line up? Horizontally or vertically?
Horizontally.
Yep. So if you want to do a quick sketch, you can. Write 4 down 2, write 3 down 2. Lines up horizontal. So what letter does that mean I want to put first?
X.
X. So you're going to have x minus something squared, y minus something. Okay, remember now you're going to put in your center. Okay, always put h with x, k with y. H comma k. So we're going to have x minus 1. What's going to happen when I plug in k? K is -2. James?
It's going to turn to y plus 2.
Right. Instead of writing it as y minus minus 2, just write it as y plus 2. Okay, and there's your equation. Questions on that one? Right, so the last one we'll do, that'll be a discuss. But what do you think you're going to have to do in this last one? Same thing we've done past couple days for the last problem. It's going to be in a format it's not at all ready to discuss, so we're going to have to do what?
Like, complete the squares.
Yeah, probably something crazy like that, right? Yeah. A day of conics wouldn't be complete without completing the square. So we'll complete the square. Okay, so remember your rules for completing the square. Put your constants on the other side. Coefficients of all squared terms have to be 1. Okay, So what I'm going to do is put the x's next to each other, and I'm going to factor something out. What do I have to factor out of my x's to make the coefficient of x squared a 1? I'm going to factor out a negative 1. Don't forget about it, because that's going to be important when you complete the square. When I ask you the question, what did you add to both sides? Okay, you got to factor this in, or factor it out in this case. It's kind of a math joke. So x squared plus 2x. All right, leave a little space there so when we can complete the square. Okay, for my y terms, I'm going to factor out a 4. And you're going to hope that everything is a multiple of what you just factored out. If it's not, you're going to get decimals. All right, so factor out a 4. This is also a multiple of 4. That's good. Okay, now we'll complete the square. Okay, Cody, what am I going to add in the first parentheses? Okay, how did you get that? What did you do?
I don't know.
Gotcha. Anyone help him out? What are the 2 steps you have to do to complete the square? Yeah.
Take half the middle term and square it.
Yep, take half of the coefficient of the middle term and square it. So half of that is 1. 1 squared is 1. All right, so Cody, you want to try again for the second one?
Yeah, that one would be 4.
4, yep. Take half of that is negative 2. Square it, you get 4. Okay, so now my question that sometimes stumps some people. What did I add on the left side? Yes? 15. Great. That's exactly what you added. Does everyone see why we added 15? We had 16 in the second parenthesis, 4 times 4, and we took away 1 in the first, and you distributed out. So make sure you add 15 on the right. Okay, now if we've done everything correctly, this should factor very nicely, and it does. It's x plus 1 squared plus 4 times y minus 2 squared. And negative 11 plus 15 is 4. Okay, so it's a lot better than what we started with. It's not perfect. There's a couple things we got to fix, but we're getting there. Okay. Anybody tell me one of the 2 things I have left to do? Darren? Yep, divide everything by 4. Okay, let's start with that. So we're going to have negative x plus 1 squared over 4. The 4's are going to cancel there. Equals 1. Almost in the format we want. What's the last thing I have to do? James?
Something with the, because isn't the larger ones used to be on the left? Or something like this, isn't it?
Well, there is always supposed to be something that's on the left here, but it's not necessarily the larger denominator. We don't know if it's the larger one. Yeah?
Would you flip the x plus 1 squared and y times 2 squared?
Just flip the numerators, or move the entire thing? Yeah, we're going to take these 2 fractions and just switch places. Standard form of a hyperbola always has the positive first, the negative second. Okay, and if you were taking a test and they asked you to identify the conic section, is this a hyperbola, parabola, ellipse, circle? This is how you'd identify it's a hyperbola. You have a minus, in between the two terms. If you had a plus, then it would become an ellipse. If you had a plus and the two denominators were the same, that'd be a circle. Okay, you're not going to have to identify it on the test. I'll tell you which one it is. All right, so now we can discuss it. Okay, H, 2. K, -1. Jill, what's A?
1.
Yep. As long as you have it in the standard form, the first denominator, take the square root of it. That's A. Square root of your second denominator. That's B. And then C is going to be the square root of 5. I like to do the vertices and foci last. I usually start off with the center, because that tells me the point that I'm shifting everything from, and then figure out the transverse axis, and that'll tell me up, down, left, or right.
Wouldn't it be K2 and H -1?
Thank you. Yep. So H is always with X, K is always with Y. So we had H and K switched. Thank you. Okay, so H with K, I'm sorry, H with X, K with Y. Okay. Everything else, though, let's see. A is right, B is right, and C is right. Everything else was okay. All right, so our center is -1, 2. Okay, and if you look at what's positive this time, it tells us which direction the transverse axis goes in. Okay, Andy, what direction does that axis go in?
Vertical.
Yep, it's going to be vertical. So we're going to be above and below the center. Okay, for the vertices, we're going to be above and below the center 1 unit. Okay, James, what's 1 unit above the center? So as a coordinate, what would be the location? Yep. And how about 1 unit below the center? Yep. Okay, for my foci, I'm going to go square root 5 units above and below the center. This one I would just use plus or minus. It's 2 plus square root 5 and 2 minus square root 5. And last thing is our asymptotes. Okay, if you look back, they had this equation, which if you want to memorize this equation for the asymptotes, that's fine. You can just memorize it. Okay, or, that's you. If you remember your equation for point slope form, that's all that it is. Y minus y1 equals m times x minus x1. Just remember that the point that it's going to go through is the center. So there's your point, and your slope is a over b. When it's vertical, v is a over b. So my equations are going to be y minus. Now we're using h and k. When you learned it in Algebra 1, you probably did y1 and x1. So we have, this is x1, this is y1, if you want to think of it that way. So it's y minus 2 equals 1/2, and remember, 2 asymptotes, positive or negative, times x minus x1. And that's the equation of your asymptotes. If I was going to sketch it, I would probably distribute out the 1/2 and then add 2. That would get it in y equals mx plus b form. But you'd have to distribute it twice. Once as a positive 1/2, once as a negative 1/2. And add 2 to both sides. questions on that? Right, so if you ever get stuck, you can always go back and look at your table. But I think if you try to do it the way I did in class, kind of using common sense, you're shifting up and down, left and right for your vertices and foci, that helps you to not have to try to memorize this whole table. All right, so the homework will be in the packet. This will be the last day using the packet. We'll go back to the book tomorrow. So on page 411, okay, I'd like you to try 13 to 16 all. 17 to 21, just the odds. 29, 31. Okay, 37 to 41, that's just odds, and then 53 and 55. Okay, that's a little bit of everything. A little bit of graphing, some matching, and some discuss type problems. So we'll go over that tomorrow, and then we'll start chapter 10.